Okay, very good morning to all of you students. So today we can continue our topic of physics, that is system of particles and rotational motion. Okay, yesterday you have learned about the center of mass for two particle system and n particle system. Okay, as well as you have calculated the center of mass for the velocity vector or acceleration vector for the center of mass. Okay, so that things we have learned. Today we can proceed for the different points, that is the momentum conservation and motion of center of mass. So now first of all, sir, what is exactly momentum conservation? You know, law of conservation of momentum states that if no external force acting on the system, the total momentum of the system will be remains conserved in an isolated system. Okay. So now here in that case, we want to prove if that conservation takes place, then what will be the motion of center of mass. So for that I will consider first of all the external force according to Newton's second law of motion is given by F is equal to rate of change of momentum with respect to time. So rate of change of momentum dp by dt, and so that is equal to d dt of m into velocity vector of center of mass. Okay, F is equal to d dt of m into v center of mass. So that will be the external force which is acting on the body. Okay. So now here in that case, if I will take m outside, then what will be left here inside? D dt of velocity of center of mass. And you know d dt of velocity, that will be acceleration, m into acceleration of center of mass. Okay, so that will be the force F bar. Okay, so that will be the also external force. But now if you want to, that means find out the conservation, if I'll say if that external force acting on the system is 0, okay, if that force is 0, then we can also say that d dt of m into velocity of center of mass, that is equal to 0. Okay. So now derivative of certain term is 0 means what we can conclude? We can conclude that means this term will be remains constant, because derivative of constant term will be always 0. So therefore m into velocity of center of mass will be always remains constant. Here in that case, that can be written as m1 v1 plus m2 v2 up to dash dash mn into vn will remains constant. Okay, you remember that things. If here m is constant, then velocity of center of mass should be remains constant. Okay, so now you see here, if no external force acting on the system, the velocity of center of mass will be remains constant, because mass is always remains constant. So here what it implies? It implies that if no external force acting, then the center of mass of any rigid body moves linearly along the same straight line. Okay, and what it proves? That proves the Newton's first law of motion. If no external force is acting on the system, body will be remains in the state of rest or uniform motion. Okay, so the body will remains in the same state of motion, that is linear motion. So that for velocity of center of mass, motion of center of mass will be along the same straight line. Okay, so that is your momentum conservation and motion of center of mass. Okay, next point we want to learn the center of mass of a rigid bodies. Okay, so second point we can continue the center of a mass. Okay, I will take this point, center of a mass, center of a mass of rigid bodies, Okay, so now question arises on what factor the center of mass of the rigid body depends. The center of mass is the fixed point of any geometrical body, okay, that is the fixed position with respect to all other particles. So that center of mass depends upon, position of center of mass depends upon the geometrical shape of the body. Which on what factor it depends? It depends upon the geometrical shape of the body. Okay, geometrical, that is the geometrical shape. Okay, so that is the point. And second point, it also depends upon the distribution of mass. Okay, on what factors it depends? The distribution of mass inside the body. Okay, on these two factors, center of mass of the body will be depends. If a body have a regular geometrical shape and the distribution of mass is uniform all over the body, then the center of mass of that rigid body is exactly lies at its center or the middle point of that body. So that is called as the center of mass of that rigid body. So for example, what exactly you want to say? Here I want to explain you like this. Suppose if I can take a long thin rod. Okay, so the long thin rod have the center of mass of its middle point. If for example 10 centimeter rod if I consider, then the center of mass, the position of center of mass will be exactly at 5 centimeter. Okay, or if I will take any rectangular lamina, so the point of intersection of the two diagonals will be the center of mass of that your rectangular lamina. Okay, if I will take the triangular shape, then the centroid itself is the center of mass. If I join all the three diagonals of that, or we can say that medians of that triangle, then the center of that point that is called as the centroid is the center of mass of that regular shaped body. So we can prove that things also. If suppose I want to explain you the center of mass of uniform rod, center of mass of uniform rod. Okay, sir, how we can find out the center of mass of a uniform rod? It's a very simple. If I will take any rod like this, okay, this is the uniform rod. So now here in that case, if I will take the any point, suppose this rod having the mass m and L will be the length of this rod. Okay, and if I will take one small portion of that rod is supposed to be having a distance of x centimeter from the center. Okay, now sir, how we can find out the center of mass and how we can prove that center of mass will be lies at its middle point? So for that, what I will do, first of all I will calculate the linear density of that rod. Linear density can be calculated by using the formula mass per unit length. And if I want to find out the mass of that your small portion which I have cut it or I have taken of that rod, suppose that dx will be calculated by, that is the dm is equal to lambda into dx. Okay, and if I want to find out the center of a mass, so then I have the, that means as this is the x-axis only, so therefore x center of mass can be calculated by using the formula 1 upon m. Okay, and limits are varies from 0 to L. Okay, x into dm. Okay, the further point I will calculate here. So how we can find out that center of mass further? So if I will take that x center of mass is equal to 1 upon m into x into, so what is the dm? Lambda into dx, and limits are varies from 0 to L. If I will take lambda out, lambda by m integration of x into dx, and that means limits are varies from 0 to L. So lambda by m into integration of x will be x square by 2. Okay, limits are from 0 to L. If I will take lambda upon m into 1 by 2, and if I will put L square minus 0. So what is the lambda by the way? Lambda you have given m by L into 1 by m into 1 by 2 into L square. M will get cancelled, L will get cancelled. The answer will be L by 2. The center of mass. Okay, so that will be the x center of mass of the rod will be L by 2. So this is way how you are able to find out the center of mass of that any regular shaped body. Okay, which have the perfectly, that means geometrical shape, and mass is uniformly distributed along that body. Okay, so I will give one example to you on that center of mass. Okay, now you can take this example, we will solve that example, you will get the idea about that center of mass. Okay, so you please write down the sum. I will give the sum to you. The particles of a masses 100 gram, first mass he has given, that is m1 is equal to 100 gram, means how much kg? In kg 0.1 kg, so that is the m1. m2 is equal to 300 gram, 300 gram, so that is equal to 0.3 kg. Okay, so that is the m2. And he has asked you at a given time have the positions, that is first position vector he has given to you, that is r1 is equal to 2I plus 5j plus 13k. Okay, and r2 is equal to minus 6I plus 4j and minus 2k. Okay, again I'll repeat, 2I plus 5j plus 13k and minus 6I plus 4j minus 2k meter. Okay, respectively. And their velocities are v1 is equal to 10I minus 7j minus 7k. Okay, minus 7k, instead of minus 7k you can take minus 3k. Okay, so this is the first velocity vector, and second velocity vector is 7I minus 9j. Okay, that is the minus 9j and plus 6k meter per second. Okay, respectively. Determine the instantaneous position vector, means r center of mass and velocity of center of mass. Then I can solve, that means I can calculate for you at least one problem, that is what is the r center of mass. Okay, so now the r center of mass can be calculated by using the formula RCM is equal to m1 r1 plus, okay, m2 r2 upon m1 plus m2. Okay, and here in that case we can put the value of r center of mass. What is the m1? 0.1. what is r1? 2I plus 5j plus 13k plus m2 is equal to, what is that? 0.3. r2 will be, what is that? Minus 6I plus 4j minus 2k. Okay, and divided by total mass will be 0.1 plus 0.3. Okay, you have to solve now this sum. Okay, how to solve now? You just multiply that things, 0.2I plus 0.5j plus 1.3k. Okay, so this is the first vector, plus here plus and minus 0.1.8I, okay, plus 1.2j and minus 3 2s are 6, 0.6k upon 0.4. Now you see here 0.2I and minus 1.2I, that answer will be minus 1.6I. Okay, now here j component, 1.2j plus point, that is the 0.7j. Okay, so that answer will be 0.7j, and that answer will be minus 1.3, and this, that will be 0.7k. Okay, plus 0.7k divided by 0.4. If I multiply by 10 on both sides, then answer will be minus 16I plus 7j, okay, and plus 7k divided by 4. Okay, so that will be the your right answer. Okay, so you can just check it, answer minus 69 plus 17j. Okay, 17j will be here, that answer will be 17, means here 1.2 plus 0.5, that answer will be 1.7j. Okay, and so therefore this answer will be plus 17j, and plus that will be 7k and divided by 4. Okay, so that will be the correct answer. Okay, similarly you can calculate the velocity of center of mass, and for that which formula you will use? m1 v1 plus m2 v2 upon m1 plus m2. Okay, you can do at home that things. Okay, today this topic. That's all.